Good morning, students. Today we will discuss about simple harmonic motion. So before discussing simple harmonic motion, first we will discuss about periodic motion. So what is periodic motion? The motion which repeats itself after regular interval of time is called periodic motion. For example, the planets are revolving around sun is an example of periodic motion. And you as your daily activity, you start from home, and after doing your activity, finally you reach at your home. This is also an example of periodic motion. So these are all examples of periodic motion. And then oscillator motion. Oscillator motion is a special case of periodic motion in which, for example, if this is a periodic motion, means the particle, the uniform circular motion is considered as a periodic motion. In this case, if we confine the particle between two extreme points, then the particle is moved like this, and this is an example of oscillation. It is basically to and fro motion. Again, simple harmonic motion is a special case of oscillation in which the particle and the force is minus kx, which is called restoring force, and this force is responsible for simple harmonic motion. In this case, at x equals to 0, force will be 0. This position is called mean position or equilibrium position. Means the net force is 0 at this position. For example, a spring mass system. In this case, if the spring at its natural length and there is a block attached to the spring, and this K is called force constant. In this case, as you know, at this point there is no force on the block, so we consider this as our mean position, and this position is called equilibrium position, where force is also 0 from this equation, and this force is called restoring force. This force is called restoring force. Now, if we slightly displace this particle from its mean position, we can take it to the right or take it towards the left. That means, if we expand the spring from this position, this is the expansion length of the spring, and I have took the particle at a distance x from its mean position. Then, as you know, the spring will apply a force in the opposite direction of magnitude kx. Now, the displacement of the particle is towards right, and the force on the particle due to the spring is towards left. That's why the force is opposite to the direction of displacement. That's why we have applied a negative sign. So this force is called restoring force, and the tendency of this force is to bring the particle back to the original position. And from this F equals to minus kx, we can write force as mass times acceleration, which is equals to minus kx, and here acceleration can be written as minus k divided by m into x. So A equals to, we can write it as minus omega square x, where omega is equals to square root under k by m. This omega is called angular frequency, and this k is spring constant, and m is the mass of the particle.